Today's episode dives into three very different frontiers of AI: how to make massive distributed pre-training resilient to failures and stragglers, how verbal critique can sharpen large language model reasoning without extra training, and why even the best vision language judges still miss critical errors. From fault-tolerant training at trillion-chip scale to step-by-step self-correction and the hidden blind spots of AI evaluators, these papers reveal both the power and the limits of modern AI systems and what it will take to make them smarter, sturdier, and more trustworthy. Let's explore the first paper, Decoupled DLoco for Resilient Distributed Pre-Training. Decoupled DLoco replaces synchronous SPMD pre-training with multiple independent learners plus a CPU resident synchronizer, breaking the cluster-wide lockstep barrier that makes standard data parallelism fragile under stragglers and failures. Each learner runs local AtomW updates on its own data shard. The syncer asynchronously aggregates non-overlapping parameter fragments using a minimum quorum K, an adaptive grace window, and token-weighted merging, then applies an outer optimizer, typically SGD with Nesterov momentum. The paper's key algorithmic novelty is fully decoupled, fragment-wise reconciliation. Learners never block on peers. Failed or absent learners are excluded from a step, and recovery is handled by replaying missed fragment updates. So localized faults remain isolated to one learner's blast radius. The system adds balanced tensor fragmentation, which greedily bin packs tensors into P fragments to smooth bandwidth and avoid bursty communication, and radial directional averaging, RDA, which averages gradient norms and directions separately to stabilize merging when learner updates are near orthogonal. Outer gradients can also be compressed to int4 with negligible quality loss relative to BF16. In simulation with up to 2 M chips and MTBI chip equals 1 year, the method sustains strictly zero global downtime and up to 100% uptime, while elastic data parallel falls to 850% goodput at 1,2 M chips and 40% at 2,4 M chips. Decoupled DLoco reaches 88% goodput at 2 M chips and 86% at 4 M with M equals 16. Across Gemma, 4 dense models from 2B to 9B parameters and 2 8B3. 8B activated MOE models, it matches monolithic data parallel on text and vision benchmarks, including ARC, BoolQ, HelloSwag, MMMU, Coco Captions, and TextVQA, and preserves post-training performance after Gemma-style fine-tuning. It also enables scavenged and heterogeneous compute, including TPU-v5e, TPU-v5p mixes with comparable quality and dramatically lower bandwidth than data parallel. Let's explore the second paper. Process supervision via verbal critique improves reasoning in large language models. Process supervision via verbal critique improves reasoning in large language models, identifies critique granularity as a fourth inference time scaling axis distinct from chain depth, sample breadth, and learned process reward models. The proposed verbal process supervision, VPS, is training free and performs iterative generate, critique, refine at inference time. A stronger supervisor LLM issues step-indexed natural language critiques over an actor's reasoning trace, and the actor regenerates while preserving steps marked correct. This replaces scalar outcome feedback, as in reflection, with dense process supervision without gradient updates or human labels. Across GPQA Diamond, AIME 2025, and LiveCodeBench v6, VPS is tested on closed and open model pairs including GPT-5, 4 high, low, GLM-5, 1 with Nematron, 3, Super, Gemma 431B, with GPT-OSS 20B, and GPT-OSS 120B with GPT-OSS 20B. On GPQA Diamond, GPT-5, 4, high supervising, GPT-5, 4, low reaches 94.9% at R equals 4, exceeding the reported 94.1% SOTA and improving over the standalone actor by 2.1 points. On AIME 2025, weak actors at 11.726.7% are lifted to 63.390%, with gains up to plus 63.3 points. At matched inference compute, VPS outperforms reflection by plus 8.5 to plus 12.1 points across all 3 benchmarks and beats. Self-consistency at 5 by plus 5 points on GPQA and plus 8.3 points on LiveCodeBench, isolating step-level critique as the causal variable rather than extra compute. The benefit scales strongly with supervisor-actor headroom. Pearson R equals plus 0.9, but collapses in code synthesis, where runtime errors are not linguistically representable, motivating hybrid verbal executable supervision. Let's explore the third paper, Seeing Isn't Believing, Uncovering Blind Spots in Evaluator Vision Language Models. The paper introduces Focus, a meta-evaluation benchmark for testing whether vision language models used as judges actually detect errors in other models' outputs. It covers both image-to-text and text-to-image evaluation, using 600 I2T prompts from benchmarks such as MMBench, MMDocBench, Touchstone, VisitBench, Wild Vision, Simple VQA, and Real-World QA, plus 750 T2I prompts from MJBench, T2I, CompBench++, T2I, ReasonBench, R2I, Bench, Text Atlas Eval, and Spatial Gen Eval. From these, the authors construct 4,089 human-validated, perturbed instances via a human-in-the-loop pipeline using Gemini 3.1 Pro and Gemini 3 Pro image, spanning 40 perturbation dimensions, grouped into categories like visual grounding, semantic interpretation, visual reasoning, long-form generation, visual fidelity, scene coherence, physical plausibility, and text rendering. They then benchmark 4 frontier evaluators, Gemini 3.1 Pro, GPT 5.4, Claude Opus 4.6, and Qwen 3.5.3.9.7b A.1.7b under single answer scoring, pairwise comparison, and reference-guided scoring, each with vanilla, rubric, rule, axis-based, and axis plus rubric variants. The central result is that evaluator VLMs have substantial blind spots. They often miss valid perturbations, with failure rates exceeding 50% in some settings. And they are especially weak on fine-grained grounding, compositional reasoning, and physical plausibility. Pairwise comparison is consistently the most robust paradigm, while single-answer scoring is the least reliable. Reference-guided scoring is intermediate and does not outperform the best pairwise setups, unlike prior text-only evaluator findings. Gemini 3. 1 Pro is the strongest judge overall, but even it fails systematically. An increasing reasoning budget does not reliably help. That's a wrap on today's AI paper highlights. Thanks for watching.